actually producing demographic data and walk through that process with you guys. Rebecca got her bachelor's in geography at the University of Colorado at Boulder. Among other things, she worked on the GIS team at the National Renewable Energy Labs doing spatial analysis and geovisualization, data visualization. She just finished a 2-year fellowship at the Institute of Health Metrics and Evaluation, IHME. And so for those of you who've already taken a look at assignment 4, IHME is the organization that produces the data and the data visualization tools that you guys are going to be using. So Rebecca worked with that data for the last 2 years, and she is currently still a researcher at IHME and also a graduate student in the geography department here. So let's welcome Rebecca.
Thinking about it here. Okay, how's everyone doing on this lovely Thursday afternoon? Okay, so I'll just cut right to the point. The purpose of today's lecture is to empower you. So we've been talking a lot about the theoretical, right? About how the demographic data is collected, what is gentrification. I want to get into the practical today. So I'm actually not going to focus on geodemography specifically. What I want to do is I want to talk to you about what it takes to develop a specific skill set that you can use for yourself and for your future career if you want to in terms of doing data science. So you, all of you, if you would like to, can get involved in the data science and visualization community. So over the course of this lecture, I want to convince you of a few things. So first, that there's a treasure trove of data that's interesting and online and waiting for analysis. And then I'm going to suggest a few different websites that you can look to start finding it. Second, I want to show you that you as an individual can meaningfully participate in the data science community and in this dialogue, partially by learning the skills that you need for free. So you don't necessarily have to spend thousands of dollars on a class at UW to get the talent that you need. Third, that you're part of a new generation of citizens and scientists who are growing up with an explosion of publicly available data. So although data science certainly has its limits, there are a lot of questions that we could be answering with the data that's available that we aren't answering yet. So I'd argue that data science has become a part of our everyday life. So I think it's gone mainstream. So this here is a screen cap. Do any of you guys use the website 8Tracks? Yeah, a handful of you. So 8Tracks is a website where you can put together your own playlists, you can distribute them. It has to have some mix of artists and albums so that you can't just publish Beyonce's new album online for everyone to see. But what's interesting about this is that now when you click on it as a user, it says see statistics. And other than just a pure play count, they also give you a song-by-song breakdown of how many people hated the song you put in your playlist and skipped it, which is fascinating. So what about Zillow? Have any of you guys used that for rent? Okay, a handful of you. So not only do they have the pictures of the properties that you would be renting, but they also have all this other stuff, right? Has anyone paid attention, like what's going on up here when they're looking at rent? Yeah, what have you guys used it for?
It shows like the estimate for how much the house has been worth throughout time.
Yeah, so it's estimates of how much they think it might have been worth, what they sold it for. It's basically to give you a sense of whether or not you're being cheated, right? Like, is this a good deal? Are they underlisting it? Is there a reason why they're grossly underlisting it? So here's an example of an individual. So this is where you come in, right? This is a screenshot from an Etsy shop. What this guy does is he takes open source street layers, puts them on a black background, and sells them for about $10 a pop on Etsy. And what you're paying for $7.80 plus tax is the ability to download that image. Like he's not even printing it out for you. He's not spending money on toner. This is just pure intellectual marketing of what's an open source data product that you yourself could download and give someone as a Christmas gift if you wanted, right? Find a nice printer. So here's a maybe more meaningful to some data visualization that someone's selling on Etsy. So this is a breakdown of the Quran by chapter, different revelations and page lengths in the chapters. That might be something meaningful that you could give someone, or if you want it on your wall as a representation and reminder of your faith. So at this point, some of you are wondering, where do I fit into this, right? Like, how many of you guys think yourself as data scientists? A couple of you, right? How many, think maybe there are some hangups here? Like, maybe I would if it weren't for X, Y, and Z. So let's start with the first one. I stopped taking formal math classes. Couldn't take a derivative if I tried, if someone was holding a gun to my head. I haven't done calculus in a while. It's just been a while since I took math. That's okay. So from personal experience, I stopped taking formalized math classes in high school as well. I haven't taken calc since high school. Just like calculators made slide rules obsolete, a lot of the statistical packages and coding softwares and platforms that are available take some of that nitty-gritty of the math out of it for you. So the world is open book, right? Like, when was the last time, if you were actually working on a project that wasn't for a class, you didn't have access to Google? Like, you don't necessarily need to know how to derive these calculations by yourself anymore. So what's the next hurdle? I don't know how to code, right? Like, that all sounds great, but I haven't had the time, or I haven't had the exposure to coding languages, and I'm just not really quite sure what's going on there either. Again, don't worry. I also started coding in my senior year of undergraduate. So I first started off as a senior in a ArcGIS class that taught us how to program in Python for ArcGIS. And there was a different class that taught me how to use R for statistics. So there are a lot of ways to do statistics and geospatial statistics without using code, if you're afraid of it. I'm going to make a case for why you should use code. But if you do want to learn, then there are a lot of resources out there, and I'm going to touch on what some of those are. So what I'd like to suggest to you is that you might surprise yourself, and that you should start rethinking about how you pitch your skill set to the world. So how many of you guys are thinking either a year out, 2 years out, about what kind of job you might be getting? Some of you, right? So part of that is that it's anxious and anxiety-inducing to not necessarily have the kind of concrete experience that you might want to have on your resume. And one of the things that I'm going to argue today is that it's possible for you to manufacture that for yourself on your own time without anyone else's permission. So I want you to rebrand yourself here. And I think that there's a sense within geography that spatial data is somehow separate from like the rest of data, that it's more vanilla, and that as geographers we deal with things that has coordinates. And I think you're cheating yourself if you take that attitude. And I think that you can pitch yourself as a data scientist, if you get some skills, that has a special frame of mind, that has that quantitative spatial skill set that people who go through stats programs don't get. So as a geography student, you have a lot of leniency and leeway in terms of what classes you might take and in how you look at the world. Take advantage of that, but don't limit yourself. So plan for the day. We're going to go through a couple things. First, we're going to chat about how to think about finding a research question, where to find some freely available data. Next, we'll talk about using statistics and code as tools, and I'll give you a couple resources that you can use or think about. And after that, we'll touch on a few of the different ways that you can get your results out to the rest of the world. So what is data foraging? Foraging is a word that I'm using and made up, so you don't need to write this down. This is just a term that I'm using. Who's familiar with the word foraging? What does it mean in like normal context? Anyone want to throw it out?
Searching.
Yeah, it's like usually kind of searching and looking for food, right? Hunting and gathering type stuff. So I want you to think about how you're going to hunt and gather data. So data foraging, I think, is very convenient. Instead of collecting your own data, what are some reasons why you might want to find data rather than create it yourself? Yeah.
Time-consuming.
Yeah, super time-consuming. What about some other reasons? Very cheap. If someone else has already done it and paid for it, then you don't have to, which is great as well. So this is a screen capture, since I mentioned foraging, of the urban edibles in Washington State from a website called Falling Fruit. So if you did want to actually legitimately urban forage, there is an open source data source for you. So in terms of figuring out what it is that you're going to do, and when I say research question, I don't mean like, oh my gosh, I'm writing a thesis, I'm writing an academic paper with a faculty member by myself. I mean like I'm writing a blog post or something, there's something that I'm interested in that I want to figure out more information about. So there are kind of two dominant strategies that I found that people take. One is that you find the data first, and the second is that you find the question and then you look for the data. So let's talk about the first strategy. I'd argue that there's a lot of public data waiting to be analyzed, and one of the reasons for this is that Obama, thanks Obama, in May 2013 signed an executive order called the Open Data Initiative. Has any of you guys heard of that? So there's a big push for government data to be put online in machine-readable, convenient formats. And this is supposed to be the standard going forward. It's supposed to increase transparency, scientific engagement. It's just a general policy. So what are some things that I found that are open source online right now? So you can take a look at the MDs per capita. So how many doctors there are per people who live in counties. Simple stuff like population density. What about unemployment? So this is in 2007. This projector really washes out these colors. But you can see there's a lot of zeros, right? This is before the financial crash. There's not a whole lot going on in terms of unemployment in middle America. You switch that to 2010, and you can just look at the distributions on this bottom left-hand corner and see what a different picture it is after the financial boom and why many people were feeling that recession in acute ways. So you can also look at fun variables like places to buy alcohol per capita. So maybe there just aren't a lot of people in Montana compared to the number of bars. Maybe it's legislation related. If you're not into finding data, if you get into this, at some point you can simulate data. So this is from a project I did last year. These are all very plausible looking data values that are entirely fake. So there's nothing true about these maps at all, which can tell you how compelling graphics can be in the face of entirely made up stuff. So those are some of the kind of rough options that you have in terms of looking, just broadly scrounging around the web. So the other strategy is to find a question, right? You found something that you're interested in, and say you're interested in automobile accidents. What are some data sources that you might want to look for? What kinds of things might you want to look up? Like you drive a car. Yeah.
Car insurance?
Yeah, maybe car insurance. So that might be tough to find because it's proprietary, but you can take a look. Anyone else? Yeah, totally. Police department, stuff like DUIs. So what about time in cars, right? If you want some sort of denominator, like how many times do people crash compared to how long they spend in the car? So the census has some stuff on that. You can look at how people get to work, how long it takes them to get to work. You can also look at fatal highway crash data. So whenever there's a car crash that someone dies, they do a big report on it. So you could scroll through some of that. You could also look at workplace accidents, right? If people are driving cars for their profession, then OSHA will often write a report. So this is just an example of the kind of thought process that you can go through if you're interested in a specific topic. So in terms of sources for data, I'm just going to go through a couple of them. Have you guys ever used data.gov? Yeah, a couple. So it's relatively new though, right? So Obama put that into action in 2013 and they're starting to implement it more and more now. There's now also healthdata.gov, which is a kind of more medical-oriented subset of data.gov. You can also look at the National Historical Geographic Information System, NHGIS. So in ACS and FactFinder, you can't look up censuses that are way back in time. So NHGIS has taken all that really nasty paper files that maybe you could find on like tapes somewhere in DC in a basement and has put that into a readable format where you can download shapefiles that have a unique ID that links up the data with the geography that you're using all the way back to like the 1600s. It's great for some of the data. So only problem with looking for data after you find the question is that the data that you want might not exist. So maybe it only has some of the people that you want. Maybe it has systematic missingness or suppression. Does anyone want to tell me what suppression is in terms of like data context? Anyone have a good sense?
Together or what? Together?
Yeah, so sometimes they can suppress data by aggregating groups more than they otherwise would to protect privacy. So it's not telling you a finer resolution of data because they're worried and concerned about people's privacy. Maybe it's not the right space-time. Maybe they own it and they want you to pay money. Yeah.
Is the suppression what they do with the census to like mimic it where you can't tell to a certain level like who?
In part. So when I think of suppression, I actually think of a data set that in general is published for the entire United States, but then they say for counties that are less than 100,000 in population, we're not going to tell you how many people are born in those counties because we don't want to violate anyone's privacy. So there are statistics that are available for some of the spatiotemporal extent, but not all of it. Whereas the census kind of blanket says, we're not going to give you this information at the block level because it's too fine and you might find out something that you shouldn't from it. So any other questions? Can we go on? Okay. So say you found the data. now what, right? So thinking about yourself as a statistician, whether you currently perceive yourself as one or not. So who can tell me what a statistic is? Like off the cuff definition. Right, like we throw around the word statistics a lot, but what is a statistic? Like one of them.
It's a database of numbers. Database with numbers.
Not quite. So that would be kind of more of a like data management system. Yeah.
A number that holds certain values or characteristics.
Yeah, we're definitely getting there. So it's a number, according to Merriam-Webster anyway, it's a number that represents a piece of information about data, right? And what I think is hilarious about this is that they even give you a statistic for the definition of statistic, and that apparently it's used less than half of all their words in the English language in terms of what's in written text. So how many of you guys have heard this quote? Some people attribute it to Mark Twain, or he popularized it. Raise your hand if you agree with this. People are like, maybe, I'm not sure what answer you're looking for. So I personally hate this quote because I think that statistics are awesome. And I don't say that coming from some sort of hardcore math background. But the reality of it is that if you have all these numbers floating around, how do you make sense of that? Like if you just have this soup of numbers, how do you condense that into something meaningful? And all of the data that we have would be lost if we didn't have some way of summarizing it. So we're really good at recognizing patterns. Right, so this is a map of King County's kind of connectivity between tracks. We can kind of see intuitively what things are related to what other things. And statistics are one of those tools that you can use to summarize what's happening in your data so that then someone else can see what you see too. Maybe they're not as good at recognize those patterns as you are. So you can get something concise, right? Because if you just start telling them like, well, the minimum is this, the maximum, mean, median, standard deviation, you just start vomiting these numbers at them, eventually you're going to have so many numbers that you haven't really reduced the number of dimensions you're thinking about that data set at all, right? So there's sort of a balance between how much information you share and present when it comes to statistics, because as you add more, it becomes harder to parse out. So we saw that in the kind of GBD compare exercise. The more numbers you add, the tougher it is to make sense of it all. So we also can be terrible at seeing patterns in random noise. Right? How many of you guys have thought that, something was going on with a friend and you thought, oh man, they must be mad at me, but it turns out they were just having a bad day. Or, from a personal level, from a data standpoint, there's actually a word for this. It's apophenia. So it's perceiving patterns in what's actually random noise. So it's our human tendency to find these patterns because it's sort of a survival mechanism, right? We want to make sure that we're understanding the world around us. But statistics can help us test our understanding and say, okay, but compared to random chance, how likely is it that what we're seeing is actually just noise? Like we think that there's a difference between these two populations and that this one's dying more than this one, but is that just because the grandma died in this month and not this day and not this day, like she died on December 31st instead of January 1st, and that's what's really skewing the statistic? It's just noise? So we use statistics for a variety of things, right? We use it for description. So just purely saying what the state of the world is as far as our sample is concerned. So you have this idea of measures of central tendency. So you guys have heard of mean, median. There's another one that's commonly in there, mode. That one's not used so much. Then you have measures of spread. So how many of you guys have heard of interquartile range, standard deviation? Yeah, so those are things that we use to describe how different are things within the group, by and large. And then we have the special spatial stuff, which we like because you're in geography classes. And so that asks you, what are the trends? What's happening in this data that we're looking at? We also use statistics for inference. So it's making claims about a larger population or separation between groups or differences between groups that we wouldn't necessarily be able to assert given the fact that random chance is at play in the real world. So if you see two different traits or variables together, I don't know if you guys have ever seen the website that says kind of bad correlations. It's stuff like number of swimming pools and like GDP correlating in weird ways, like trying to figure out whether or not two variables actually track together through time and co-vary. That's one of the realms of statistics. So how many of you guys have done any modeling, like run any regressions or heard of that being done in science? So regression modeling, so stuff like linear equations and saying, y equals mx plus b, that's taking a whole bunch of different variables and saying, okay, well, how much does the distance you live away from where you work predict you walking or driving, for example? And so we have some reason to think that the variables that we have, information on this topic, would help us understand the variation in the variable that we're interested in. So that's why sometimes they're called covariates, is because we're hoping that they vary in some direction, either up or down, with our outcome of interest. So that's really asking, are the trends that we see real, and what's associated with those trends, and can we draw any causal pathways there? So in terms of what kind of analysis that you're going to do, in terms of big picture stuff, there's structured and unstructured data. So structured data is probably everything that you guys have seen and worked with. It's stuff that you find in databases, stuff that you see on websites that news articles have done for the most part. But sometimes there's unstructured data, which is kind of giant pools of machine-readable information that you have to do something to first before it becomes structured data. So stuff like, have you guys ever scrolled through old messaging logs with some of your friends and be like, wow, I was a different person in 2009? So that would be an example of unstructured data, right? Because you would need to go and use maybe text reading methods to get a sense of what was actually happening and how different of a person really, were you going through an emo phase in '09 compared to now? So statistics and machine learning can almost be used interchangeably. We usually tend to think of machine learning being the kind of big data stuff. Statisticians get irked about this because two things. One is that machine learning to some is considered a dirty word. Has anyone heard of this? It's not a good thing? So this has to do with the kind of strategy one of what I was talking about finding data and then hunting for patterns in it. And part of the problem with hunting for patterns in data is that if you look at enough cross-sections and variables, eventually you're going to find something interesting, but it could be that the interesting thing you found was just random chance, is why you found that it was there. And so you've published this result and you're like, wow, in women under 5, we found this crazy thing, but really it's just because you looked at enough variables and by odds, probably one of them would have appeared to be statistically significant. So statisticians like to think of machine learning as part of their purview, and that, statisticians have been doing machine learning for a while. All the normal modeling methods are machine learning too. So let's take an example here. There's a really great blog that this woman named Robin runs. I think she's a grad student. And so she decided to quantify the amount that she cried. Hopefully none of us have been driven to do this in our own lives, but this is her 1 to 5 scale of, how hard am I crying? And then eventually, after about 500 days, she put it all into a table. So these are some of the reasons. She's like, oh man, I was in my car, a red light camera went off, and I started crying. That was I shed a few tears, but it wasn't so bad. And then you have that 18th line, they were at home, they just were sobbing uncontrollably because their close friend was drunk driving and it made them really upset. It seems legit, right? So what do they do with this? A, they published it online, which is an interesting choice to have done, and they plotted it out. So something awful must have happened in November. I don't know what was going on in her life. If you look at number of cries, that's 16 up there. That's crazy. I hope that she's, doing better. Seems like things were getting better for her in 2015. She took a look at what days of the week and what days of the month it happened. So she's Tuesdays were not a good stretch for her. I don't really know what was going on there. So we care about place. We're geographers, right? So apparently she was crying a lot in hotels, then public transit, work, therapy. Interestingly, hotels make her more upset than therapy. And then we get into streets and stores. There's weddings. Hopefully those are happy tears. Maybe those should have been counted as negatives. So then we get into unstructured data. So this is the same chick. She's really interested in self-quantification. Have you guys heard of this? So it's basically where you start recording traits about your life and you keep track of them. So stuff like having your phone randomly alert and ask hey, are you having fun right now? And then 3 months later, you're like, wow, every time I'm hanging out with Jim, I'm actually not having fun. Maybe I shouldn't hang out with Jim anymore. So this is an example of analysis with unstructured data. So this was her looking at her text message records with her long-distance boyfriend and how often they said sorry and why. So this is a kind of category. So one is availability, sorry, I can't do this right now. This is behavior. So like, I'm sorry that I just am, you know, a failure today. I'm sorry that I didn't talk to you. I'm sorry that bad things are happening. I'm just messing with you. I'm not even actually sorry. Then they have this over time. So you can see they were sort of like, they were feeling more confident in the early relationship, and then maybe like they got a little bit more self-conscious about things, started getting more comfortable, and then they kind of mellowed out, right? So slowly they sort of figured stuff out. So moving away from this girl's personal life, we can also take a look at OkCupid. Have any of you guys ever paid attention to OkCupid's blogs? So since they've released this book called Dataclysm, they've kind of stopped updating it since 2014. But this was a kind of heat map of compared to average, preference versus the average, women rating men and men rating women, and basically just straight up racism in terms of who you thought was attractive. So you could see that you know, Asian men rated Asian women higher than average, but black women very low, right? And so the idea was that even though theoretically we've come these long ways in terms of, you know, saying, of course, interracial marriage is okay, that on the ground, it doesn't mean that people aren't experiencing these microaggressions and this lack of acceptance. So I want you to just give yourself permission to explore something, no matter how inane or specific or personal to you it might be. So this is that same girl from before. This is her mapping out what she did on her Friday nights. So she text mined her diary for like a year. So the variables are too small even for me to read here, but it's like, what did you do? Did you go to dinner? Who did you go with? All of those different questions. And visualizing these things can be a fun exercise in and of itself, and maybe you would even learn something about your day-to-day life. Any questions about any of this stuff? Entertaining, hopefully, a little bit? Okay, so what about actually doing this yourself, right? Like, clearly, the data visualizations didn't spring out of nowhere. They put time and effort into them. How do they do it anyway? So I'm going to argue that you should use code. How many of you guys have written code before? A lot of hands. That's rad. So how many of you guys have used Excel to do some sort of, like, science project? Of those of you who did both, did you like Excel better? Raise your hand. It's okay to be honest here. And then did you like code better? Right? So it probably depends on how much time you spent with each. So I'm just going to make a case for it. So you should use code, or think about using code, because you can look back at it later and figure out what you've done. It can be a building block, save you time, and maybe even you'll have fun with it, but who knows. So it's a record of exactly what you did, and that if you leave the raw files as they are, and any changes that you do are after the fact, you know that you haven't corrupted your original data. Like if you're messing around in an Excel spreadsheet using formulas, it's pretty easy to like something delete, an extra drag drop too far, and you'll never be able to find that error ever again. So it's a way to kind of protect yourself against our own human stupidity. And it also is something that you can use as a building block. So to that effect, functions and packages are really useful. So the idea that other people have already put a lot of time and effort into this is really the key here, and that's great. So anything from graphing to data analysis, one of the main benefits is that you can do pretty much anything that you want with it. So this up here is a variable, is a function that I wrote that looks at a variable in a data set and checks to make sure that there are the same number of observations for any of the given levels that I think it should have. So like if I know that I have a data set that should have numbers for every age, sex, and time, and make sure to count those and say, okay, you have the same number in all the sex groups, same number in the age groups. It's just a nice way to make sure that your data set is symmetrical. So I pass that on to other people that I work with. They use it now, things like that. So it allows you to do the same or similar tasks again and again. How many of you guys actually got an automation when you were coding? Not as many, right? So this is where it starts to actually become powerful, because it starts saving you time instead of just being a total pain. So say you want to run the same statistic again and again. You want to make a map. How many of you guys have tried to make a map, those of you who have used ArcGIS, and realized that you have to manually click through that variable to pick the other one, redo the color scheme, reset everything? There's no way in ArcGIS to automate creating a series of maps based on different variables that are using the same geography, which is super annoying. I hope someday they fix that. So you can reuse your code and adapt it later. So the language that you use is something that's up to you. How many of you guys use R? as your language. What about Python? SAS, SPSS, Stata, anything else that I didn't mention? So I happen to like R a lot. It's open source, so I'm going to touch on a little bit more about open source stuff in a minute here, but open source basically means that you can use it for free. All of its tools are available for you for free, and that it's out there for you. Python's the same way. I think that SAS, you might be behind a paywall, but if you've had any coding experience, and if you're thinking about getting coding experience, I assure you and guarantee you that the first language you learn will be the hardest. So all of the tools and ways of thinking that you develop when you're learning how to code. So what is a for loop? How do I parallelize something? How do I write a function? At that point, it's just semantics in any other language that you learn for the most part. It's figuring out, okay, I knew how to do this in R. What's like the Python version for that? So you can learn how to do this in a variety of ways. And I would argue that for a lot of people graduating, it's possible that any coding experience you have might be one of the best assets on your resume. I know that for me, it's one of the things that was instrumental in me getting a job. So you can learn how to do this here. Have you guys have interacted with CSSS, Center for Statistics, Social Sciences? It's mostly geared at graduate students, but they do have some undergrad classes in there as well. What about the eScience Institute? So UW actually had this huge big data initiative a year or two back. So consider looking into the eScience Institute and Center for Statistics and Social Sciences if you want to get involved with communities at UW. If you're thinking, okay, that's great, but I don't really want to go to any more seminars, I don't want to have to pay for another UW class, I'm about to graduate, the ship has sailed, basically. That's okay too. So there are a variety of different ways that you can learn this stuff online for either free or like a trivial, compared to UW tuition anyway, amount of money. So I think DataCamp has full series on coding in R as well as Python. I think it's like a $29 a month subscription to get access to all of it. edX is a free online course. You can actually even get certificates if you decide to do it like for a grade, quote unquote, if you want to use that towards graduate or job credentials. There's also, never underestimate the power of Google, right? How many of you guys have used Stack Overflow for a question, right? So for the most part, one of the hardest parts of learning to code is learning what search terms to use to figure out the answer to your question. Same with ArcGIS. It's knowing that what you're really looking for is a buffer/schema lock issue rather than how do I make the line fatter or encompass more space, right? It's knowing the specific technical language to use. So R bloggers is a collection of different people that have decided to say, hey, I blog in R, I do this kind of tutorial in data science and results stuff. Feel free to organize that all in one place. So I'm going to argue that scientists are becoming software engineers. So the whole kind of big data endeavor has pushed the scale of our data sets, plus the computing power that's on our simple laptops and iPads, is a lot greater than it used to be. And because of this, the expectation in science is that maybe you'll be using bigger data sets than maybe we were in the past. That doesn't mean that you as an individual need to use bigger data sets, but they're out there for you, and a lot of the tools that are being developed are designed to scale as things get bigger. They're designed to be really, really fast, so you can crunch through a lot of data in specific, specific operations. So for example, in my work, we mostly use R, but then we actually call on C++, which is a kind of lower level, very, very fast programming language that is obnoxious if you're writing a big chunk of code, but if you just wanted to calculate something a bunch of different times, it's really quick at that. So you can build on your past code and build on other libraries, even across different languages once you start getting good at this. So what about GitHub? Anyone heard of that? Has any of your courses used material from GitHub or used that as a distribution? A couple nods, right? They have this fun octopus cat logo. So the reasons why you might want to use GitHub. GitHub is a version control software. So basically you say, all right, I'm going to download this folder. This is the folder where my code's going to live. And then you can check in with GitHub and it'll host it up in the cloud. And whenever you make a change, you can then say, okay, here's the change that I made, push that change to the cloud. And it'll give you basically a flowchart of the different alterations that you've done to your code and files. So this makes it really easy to stash your code so that if your computer crashes and dies, it's somewhere, virtually. So your computer can fail you. Your brain can also fail you. How many times have you guys written something or done some, assignment? ArcGIS is like infamous for this, where you create this beautiful map and then you just totally botch it, and you're like, what have I even? I went to annotated text too soon, and I can't go back, and then you end up starting over, right? So it's the idea of storing past versions and iterations of the research that you've done. It also allows you to collaborate. So one of the main draws for version control is that other people can look at your code, contribute to it. You can contribute to a code base, and that this creates a resource for others. So why do we care about creating a resource for others, right? Well, one is that it's nice to be egalitarian. It's nice to be, giving back to the community that gives up so much. But in general, it's becoming a new scientific standard. So if you are planning on participating in science or any kind of research-related endeavor in the next 10 years, I would expect to see an increasing push for transparency in your research. So this is a cited article from Source Code for Biology and Medicine, saying that reproducibility is a hallmark of good science, and that it's essential to gain trust and to develop new ideas. So about the gaining trust part, why would having your code be out there and having the data out there gain trust in science for anyone? Yeah, Thomas.
To make sure that you're not tweaking the code to get what you want out of it instead of what
Totally.
the actual data is saying.
Totally, to make sure that you didn't falsify data, to make sure that the results that you have are actually derived from the data that you started with. So to emphasize this is an email that I got this morning at 6 a.m. So this was some data science company that was really putting up a big fuss, wanting me to click and check out their data science endeavors, saying that they raised $10 million for collaborative, reproducible data science. So this isn't just a public sector thing. This is a private sector thing that this trend is happening. So there's this group called NumFocus. It's a nonprofit. So there are all these different logos are from some of the different coding and tool packages that they support. So one of those is R OpenSci. So it has libraries that have data already loaded. It has a kind of seamless way that you can say, here's the data I used, here's the code I used, here's the results that I got from it. So it's supposed to create an easy workflow for you to make your results easy to understand. So part of this is what Thomas said, that we bring biases to the table when we do research. And this is one of the things that's common in critiques of quantitative methods in general, right? Is that to call quantitative science, not subjective would be grossly misrepresenting the number of choices the quantitative scientists make when they decide how to represent and analyze their data. So what results ever make it into papers and peer-reviewed journals? What do we consider important? What questions do we even ask? Right? So there are entire subdomains of geography, like feminist geography, that's very concerned in making sure that women's voices and perspectives are reflected in science, both quantitative and qualitative. So if you make your code and data available to the public, people can look at your analysis, tweak it, use their perspective, make sure that you aren't getting into an ivory tower. So what about if you actually want to, put this out into the world, right? And you do want to get involved. My recommendation would be to start following blogs that interest you. You'd be surprised at the number of tutorials and kind of interesting stuff that's out there. So like 538 started off as a blog, I think, for example. I'd also encourage you to make a blog or put information that you've done and you've worked on somewhere, whether it's GitHub or whether it's on a few other different sourcing platforms. So RPubs is one option. So here's some of the stuff that I have up on RPubs. It's a mapping suite that I wrote for R, a tutorial on how to not mix up your data values and the polygons and shapefiles when you're using them for R. And then I'm bringing spatial data into R. So feel free to check those out also if you're interested in using R for spatial analysis, because there's this perception, I think, that ArcGIS has the market on doing spatial analysis, but many people use Python to drive ArcGIS. Many people have decided to go away from ArcGIS because their license is so expensive. So there are a lot of different ways to achieve the same goals. So a variety of other platforms exist. So Blogspot. Did any of you guys have a blog already related to like unrelated stuff? I won't look for them, obviously. But if you did, you could add up your own data stuff or things that you were interested in. Even if it's just writing up, here's an article that I read, and here are a couple problems that I saw with the methods they used. And maybe we should think critically about how this new news article portrayed this topic. So Vista was something I just stumbled upon looking. So you can create all these different graphics uploading your data. If you wanted, you could use social media. Right? One of the ways that we share and understand topics at this point is by getting that data from sources that we trust. So if you see something that your friend said, hey, I just did this analysis, the person's like, wow, I like their perspective generally. Their heart's in the right place. They probably did a pretty reasonable job of analyzing this stuff. I'll check it out. And you can give them something to cite or point to their friends when they say, is this really a problem? Is this really an issue? So, to summarize for today, do we agree that there's a wealth of data at your disposal? Yeah? Okay. The tools and skills that you need, they're there. The only thing that's missing here is your time commitment. And I know that there are a lot of different things that are time pressures on your lives, but consider going through one of these programs if you're interested in possibly making this a career or go into grad school. I think it's a good sense of, vetting to see whether that's the future life that you want. Because sitting at a desk and writing code all day is most of what I've been doing for the last few years, and it does get tiring, right? It's difficult to feel like you're impacting individuals on a day-to-day basis, and it's a good way to vet out that career choice for you and see whether or not it's something that you like. Almost everyone that I know that's happy at my job has a passion project on the side. So it's not just that they come in and code, but it's that they're like, okay, well, I'm working on this, but really I'm interested in this social justice issue over here, and that's where the passion project lies. I think that each and every one of you has something to add to these conversations. I firmly believe that. And that ultimately creating a project portfolio and saying, here are some analyses that I've done, even if it's just stuff that you've done for class, as long as you're not infringing on the content copyrights of your instructors, showing that you know how to walk the talk when they say, I've done this kind of science, I've done projects, is important to you getting hired. So that's about all I have for you guys today. Does anyone have any questions? Yeah, Jordan.
As far as mapping, what is the best thing you have with mapping? Best option is what ArcGIS mapping for you.
For me, so I personally map most of my variables in R at this point. That's because I often have done a lot of pre-processing on the data in R, and then at that point it's a seamless transition. And I also spent a lot of my own personal time writing a package to make mapping easier in R. That's up on GitHub, that if any of you guys are interested in using that package, I can shoot me an email and I'll send you a link. It's not like a widely advertised library. It's not on CRAN, so you can't download an RStudio yet, but it's out there if people want to use it. My second choice, I think, for the average researcher person, if you just want to visualize a variable, would be QGIS. It was formerly known as Quantum GIS. That's a open source platform, so you can download it. You can do the simple tasks of spatial analysis like buffering, overlays, area calculations. You can also do some image processing in QGIS. It's not as elaborate as ARC, but that also is kind of one of its greatest strengths. ArcGIS, you can get really deep into the weeds. It's also free, which people underestimate the extent to which the fact that ArcGIS license is like $10,000 means that you would need to be working for a big firm or someone that had subsidized access to ArcGIS if you wanted to use it in your career. So it's absolutely an industry standard, and that you will find jobs where you can be a GIS data technician using ArcGIS coming out of college if you have experience with map making and cartography. But often those jobs could be like, dragging and dropping points and validating images to polygons. It won't necessarily be interesting work inherently if you just see a job that comes up for ArcGIS posting, because it needs to be a big enough organization that the entry-level jobs will be truly entry-level for ArcGIS. So Quantum GIS can be used by smaller companies and smaller corporations. As far as really big data sets, there are also, have you guys heard of SQL databases? So there's a spatial extension to some databases called PostGIS, which allows you to do database queries the way that you would do for SQL, but on spatial data. So you could ask, select these data points which overlap within this radius of this other table. So you can, high-end data production will sometimes use that as well. But as far as like, that was an, overcomplicated answer, but Quantum GIS is a really great tool. Yeah. Anything else? Questions about working in data science? Anything else while I'm up here? Otherwise, I'll turn it over to Sky and talk about your survey.
Okay, let's thank Rebecca with a round of applause. And let's go ahead and take